All right, buddy, welcome back to video 2. This is where we're actually jumping into some geometric relationships. So I'm not gonna lie, this is gonna be a big part of your test. We usually put the percentages of like how much each part is, but I would guess that this kind of like identify the relationship, set up the equation, solve it, resubstitute, probably constitutes close to 50% of your test, if not more. It's just a big part of our first unit study. All right, so across the top, we have these weird diagrams with a bunch of different angles. Please recall that each one is numbered, but that's not a big deal. We can do that. We're going to pick out a couple different angles and we're going to try to recognize the structure. I'll be honest, the best way to do this is probably just by using some colors and highlighting the angles in question. Allow me to demonstrate. So for this first one, we need angle 1 and angle 6. So here's angle 1, which I'm highlighting in pink, and then here's angle 6, which I'm highlighting in blue. And so if you kind of block out or ignore the rest of that diagram, or better yet, like redraw it right here next to it, here is 1 and here is 6. Hopefully we can recognize angle 1 and angle 6 forming this line. Remember, whenever you have a line that's broken up into more than one angle, those are referred to as linear pairs. Let's see if I can squeeze that in here. Linear pairs, which also means that they're supplementary. Okay, linear pairs and supplementary are always kind of like joined together. When you have linear pairs, you're automatically supplementary. Although as found in Jeopardy, you can have supplementary that's not linear pairs. Supplementary by definition means that we're adding together to make 180 degrees. And so we're looking for the measurement of angle 1 plus the measurement of angle 6 equals 180 degrees. Squeeze in there at the bottom. Sorry to leave a ton of room. But that's the rhythm of these kind of questions. And so we're going to pick out those angle pairs, we're going to try to figure out what's going on, and then we will write an equation. So number 2, we need 4 and 3. So here's angle 4, and then angle 3 is right next to it. Okay. And so consider what they form together when combined. I have a nice square angle here. Notice that we have a square arc in the middle. That makes them add to 90 degrees, or what we call complementary. And complementary by definition means they add together to make 90. So we have the measurement of angle 4 plus the measurement of angle 3 equals 90 degrees. Recall that little m just stands for measurement, that's all. Okay, and finally we have 2 and 6. So let's find 2. Okay, and then 6. Ooh, okay, so 2 and 6, notice they're non-adjacent, meaning they don't touch and like meet a wall. They do touch at a central vertex, but they're directly opposite of one another. More importantly, they form this nice intersection where this is angle 2 and this is angle 6. And so we'll recognize those to be like the scissor angles, or what we refer to as vertical angles. Vertical angles by definition are congruent, therefore the equation has to be the measurement of angle 2 is equal to the measurement of angle 6. And so we see kind of like our basic layout here, where we're either adding things together to get a total, or we're going to have congruency. In this case, the totals were definite, 180 and 90, but they also could be generalized as angle addition or segment addition, in different examples anyway. Let's move on to the bottom. All right, so this is a question we've asked you 675 times in class. Like recognize something and give it a geometric name for it, write an equation, solve it, and then go back and do some substitution. So here's what I noticed. I noticed that we're given RG, which is 7x plus 3, and we're also given GQ, which is 3x plus 13, and then we're told the entire value from one end to the other, okay, is 56. Okay, so to me that screams segment addition postulate. It's not bisected because you don't see the congruency marks, there's no kind of angles, and so all we can really do is add the small parts to make the whole part, and that's what you're going to see in the equation. And so we'll take the 7x plus 3, okay, we'll add it to the 3x plus 13, and that's going to equal the entire total of 90. Okay, so in other words, we have something plus something equals something. Now in terms of solving it, we just got to get x by itself. And so we have some same side x values. We'll combine that to make it 10x. 3 and 13 make 16, and that's equal to 90. So now we're in our basic solving steps, or solving routine, so to speak. We're doing our inverse operations to the x by itself. So we have 90 minus 16, because we can subtract, change the colors here, green. We subtract 16 on both sides, leaving us with a 10x on the left. 90 minus 16, we have 74. And then final solve step, let's divide by 10, divide by 10, which will give us an x value of 7.4. Now, we experience a lot of freaking out about decimal values, but decimal values are numbers just like anything else. We shouldn't assume we're wrong just because we got a decimal. What we should do is take this value and substitute it back in our original equation. What I mean is, if we go to the RG, okay, we have RG is 7x plus 3, so that'll be 7 times 7.4 plus 3, and so I'm getting RG to be 54.8. And we're only in trouble if we substitute for the other value, in this case GQ, and we don't get 54.8. Let's find out. 7.4 times 3 plus 13, and I'm getting 35.2. Oh, I'm sorry, I misspoke. These can be different values. What I mean is we're only in trouble if when we add these back, we don't get 56, which was our total. Okay, so 56 was our total. So if we take RG, the 54.8, and add it to 35.2, we get 90. What the heck? 1690, 74. Yeah, 7 times 7.4 would be 9.8. Oh, I know, I see what we're wrong. You can see what we're wrong? This happens in math. It's not equal to 90. All right, so honest mistake there, it should be equal to 56. So if you were scratching your head about the 90, way to go, it should have been 56. So 56 minus 16 should be, let's see, 0, 5 minus 1 is 4. Should be 40, which means the x value should be 4. All right, okay, so the decimal in this case was wrong, but sometimes it's not. Let's go back and substitute. So 7 times 4, so RG, 7 times 4 is 28, plus 3 should be 31. Okay, and GQ, 3 times 4 is 12, plus 13 is 25. There we go, 31 plus 25 is 56. All is right with the world, we got the answer. Because RQ, the whole length, is 56. All right, cool. Well, you know what? That was a real mistake I made, guys. But that also demonstrates why you should always go back and check your work. Because if you just solve for x and left it at that, I don't think I would have caught the mistake. It is what it is. Anyway, let's move on. So here we have a segment, but we see it's actually cut up into 3 pieces. We have ML in the middle, and then we have LK at the end. And then we have the tire length that expressed as 23. So again, we don't see any like congruency marks or anything that indicates a bisector, but we do have multiple parts of the segment that we can add back to make the whole segment. And so we can do that. How does that look? Okay, well, we have x minus 6, so our first part. Okay, then we had 9 for our second part. And then the green part will be 2x minus 19. And of course, that's equal to the whole piece, which is 23. All right, so now we set up our equation to solve. Again, we got to clean up some algebra first. Let's combine our like terms. Let's hope we substituted everything properly. So we have x and 2x, both positive. That makes it 3x. Okay. So we have negative 6 plus 9 minus 19. Once combined, that'll give us a negative 16 total, and that's equal to 23. Adding 16 to invert the negative 16, of course, on both sides. We'll leave 3 x's, the same as, let's see, 20, 39. Dividing by 3, which I'm running out of space here to do, but if we divide both sides by 3, we shall get a 13. Now again, we should go back and substitute to make sure our values are all correct. So instead of an x minus 6, I have a 13 minus 6. 13 minus 6 is of course 7. 9 is just going to be 9, because there's nothing here to substitute. And then we have 2 times x minus 19, which turns into 2 times 13 minus 19. And that's going to be a 7. Okay? So if you take those three pieces together, 7 plus 9 plus 7, it should equal 23, which is our whole length, and we can confirm that equals 23, that's our whole length. All right, example number 3. They're trying to throw a curveball at you because they're not telling you this AB value. Okay? But what they want you to notice is that we have a congruency marking set here and a congruency marking set here. So given what we know about congruency marks, congruency means the same, which means the AB length and the BC length should be the same. And so this is also 2 times the quantity x minus 8. Okay? Now this is not, even though this section of the segment is bisected, please note the whole thing is not a segment bisector because we have this third section off to the right. Okay? That'll simply be added. And so our tactic overall is still going to be segment addition postulate. We're still adding things together to make a whole. In this case, we'll have 2 times the quantity x minus 8. Another 2 times the quantity x minus 8. And then our third piece, 10x. That's of course still equal to the entire thing. I'm going to try squeezing here. We have 12x minus 6. And so we end up with this big honking equation, but we're just going to do some simplifying in our next step and see if we can reduce it. All right, first we got to do some distribution. So 2 times x, 2 times negative 8 is negative 16. It should be the same for this one because it's literally the same expression. Okay, plus 10x equals 12x minus 6. All right, so now we'll draw a line. Now we actually start the combining routine and solving routine. Well, I see 2x's, 2x's, and 10x's. And so 2, that's 4x's plus another 10 makes 14. Minus 16 will be negative 32. And we still have that 12x minus 6 on this side. Okay, now in terms of solving, okay, well, let's first kick over our 12x's. Positive 12x's, of course, will make them negative. Okay, so minus 12x's on both sides. Okay, so we have 2x minus 32 is the same as negative 6. Okay, we'll add 32, add 32. And so we have 2x's are the same as negative 6 plus 32, which would be 26. And then I'm going to have to kind of maybe squeeze a work in right here. If 2x's make 26, I divide that by 2 on both sides, and we get x equals 13. All right, now the substitution routine, let's confirm our work. Instead of 2 times the quantity x minus 8, we have 2 times the quantity 13 minus 8. And so that makes this chunk 10. Okay. Which also makes the blue chunk 10. And then this weird reddish color, I don't know what color that is, we have 10 times x, and so that's going to be 10 times 13. So that's going to be 130. Okay, now those numbers look weird. Remember, we have a whole length on the bottom as well, so we need to check that. And so we have 12 times x minus 6, that's 12 times 10, which is 120, minus 6, which is 114. And that doesn't work out either. Oh, not 10. Ugh, I'm telling you what, I'm making so many mistakes. Hold on, let me back up. That's not 130, because 10, well, that is 130. That part's right. Is there an undo? There is an undo. The red part's wrong. Okay, so let's try that again. So we have 12 times 13, because x is 13, and then subtract 6, which you get 150. Okay, that makes sense, because 130 plus 10 is 150, and so is the red part as well. All right, let's continue, which is probably with a little more speed, because next we're going to be kind of the same deal. And so again, we have like the whole length, which is 250. We have this chunk, which is 9z plus 10. This chunk is 3z, but we should notice the next one, which is unlabeled, also has the same congruency marks. like this chunk right here, so that's going to be 3z as well. Okay, so equation for segment addition postulate. Oh, I don't think I was even writing that. So it's segment addition postulate. Oh man. Okay, so we have 9z plus 10 plus 3z plus 3z again equals our total of 250. Okay, combining routine, 9z's plus 3z plus 3z should equal 15z's total, plus a trailing 10 makes 250. Subtract 10 on both sides. Now we have 15z equals 240. Okay, divide out to 15 because 15 is multiplied to the z. And we get a final z value of 240 divided by 15. Is it a decimal? Oh, it's not. It's going to be just 16. Okay, and so going back to resubstitute, we have AB, our original chunk, which was 9z plus 10. That turns into 9 times 16 plus 10. Let's see if I can do this without error. That's going to be 154. Our blue segment, which is 3z, so BZ is 3z. That's 3 times 16, our z value, that's 48. Which also makes our green chunk, our final chunk CD, also equal to 48. Now to check this, we just had to add it back. So we'll take 154 plus 48 plus 48, and look at that as 250. Okay, let me go back a second. Let's squeeze in some names here. This is a segment addition postulate. Okay, this one's also segment addition. Okay, that's important. It's actually the first direction was to write down the name, and I totally ignored it, and I apologize for that. Okay, this was also segment addition. Cool, all right. Last two. All right, so chunk, well, we see that we have a congruent chunk over here, so this should also be 4 times the quantity 3y minus 8. Okay, and then we have the middle section, y plus 14. Okay, so in the addition, because this is going to be segment addition, okay, so we have 4 times the quantity 3y minus 8, plus the green section in the middle, y plus 14, plus the other raspberry color, is that raspberry? Plus 4 times the quantity 3y minus 8 is going to be equal to 50y minus 100. All right. So we draw our y. Let's do some distribution. So we have 12y minus 32 plus y plus 14 plus, again with the distribution, 12y minus 8. 50y minus 100 is on the left. Now this is a big equation, but let's reduce it by combining two terms. So we have a 12y plus a y plus another 12y. 12 and 12 is 24 plus 1 is 25y's. Then we have minus 32 plus 13. Well, that should be a 32. And many mistakes this morning. Minus 32. There we go. Okay. So we have negative 32 minus 32 plus 14. That nets us a minus 50. Oh, that's convenient. Okay, so 50y minus 100. Okay, let's move some terms around. So let's subtract 25 on both sides. It's going to be 25y's. Collect the y terms on a single side. That'll give me negative 50 on this side. 25y's. Wow, that's not what I said at all out loud in my mouth. 25y's. 25y's. There we go, minus 100. All right, so let's add 100 on both sides. Okay, so that gives me 50 over here, 25y's over there because they're gone. Divide both sides by 2. Okay, and then y is going to be 25. Okay, let's go back and do some substitution. My personal favorite part. So we have AB, okay, which is 4 times the quantity 3y minus 8. So 4 times the quantity 3 times 25 minus 8. And so that nets a 268, which which also means that CD is 268 because they're congruent. Okay, and then BC is y plus 14, so that'd be 25 plus 14. Okay, and then we have the whole chunk AD, which I'll go in red, is 50 times y, so 50 times 25 minus 100. So the entire thing, yeah, okay. So we have 50 times 25 minus 100, so 1150. Okay. So let's go ahead and pause it here, and I'll see you all in video 3.